Welcome back. So today we're getting into the real meat of linear programming. This is where we're going to throw context into the problems that I was asking you to solve yesterday. So the easiest way to perform these linear programming problems is to make everything into a table. So usually you're going to be talking about a certain product, okay? Those products you turn into your columns. All right, so in this first one, our products are going to be t-shirts and sweatshirts. So that's going to line up across the top plus a totals column. All right. Then any information you get about the products, you make down into your rows. All right. So here you'll see we get information about the minutes, the amount, the cost, and the profit. So that's how you're going to work on constructing these tables. And again, tables are the best way to arrange this information. So let's read our problem. You're screen printing t-shirts and sweatshirts to sell at a blues festival and are working with the following constraints. You have at most 20 hours to make t-shirts. You want to spend no more than $600 on supplies. You want to have at least 50 items to sell. All right. So what do we know? Well, the t-shirts take 10 minutes to make, the supplies cost $4, and you profit $6 on each one. Right? And then the three-color sweatshirt, it takes 30 minutes to make, the supplies cost $20, and you make $20 off of them. So let's see what we have going on. So you have at most 20 hours to make it. Well, it says here it takes 10 minutes to make a t-shirt. It takes 30 minutes to make a sweatshirt. And you have at most 20 hours. Well, 20 hours we have to convert to minutes. So that's 1,200 minutes. Now the number I'm going to come back to. Right now all we know is we want at least 50. The cost, well, it says it costs $4 for the t-shirts, $6 for the sweatshirts, and we want to spend less than $600. And profit, we profit $6. Oh, whoops, I'm sorry. I put the wrong information here. The sweatshirts take $20 to make. You get $20 of profit, and we want to maximize the profit. All right, so now what it says, all of these t-shirts, the t-shirts are going to be represented by X. The sweatshirts are going to be represented by Y. And we're going to turn all of these into constraints in the objective function. All right, now the objective function is the easiest. So you want to identify what you're trying to maximize, and that becomes your objective function. So what would we be trying to maximize here? Well, we're going to try to maximize our profit. So I'm going to take this right here. That becomes my objective function. So what I end up with is 6 x's and 20 y's. So that's why I put the x and y on top. So what that's saying is per t-shirt and per sweatshirt. So that's what that's really saying. And that's going to be our profit. So our objective function, we're trying to maximize that profit row, okay? And the rest of everything, every other row, is going to become our constraints. So let's go back. Let's look at this row, the minutes. 10 minutes per t-shirt, 30 minutes per sweatshirt, and we only have up to 100 or 1,200 minutes to work. So again, 10 of those X's and 30 of those Y's, and we only have up to 1,200 to use. Okay, we only have 1,200 minutes. What else do we know? Well, for numbers, we want at least 50. Look, I left these blank because it doesn't really make sense to put ones in there. But if I have X t-shirts and Y sweatshirts, can you see that that's how I'm going to get that 50? So that's why I left that blank, just because it didn't really make sense until we put the variable in there. So the number, I want at least 50. Oops, I'm sorry. So at least means we want greater than 50. Oh, went in the wrong direction. And then for cost, $4 per t-shirt, $20 per sweatshirt, and we want to spend less than $600. Now there are two other constraints we have to consider. Because we're talking about real world situations here, you also always want to clarify that you're talking about numbers greater than or equal to 0, okay? You're always going to tack those on at the end because again, real world context, you're not going to have negative numbers. Now, the nice thing for you is on your test, this is as far as you're going to have to take it. On your test, all you're going to have to do is fill in the table, write me your objective function, write me your constraints. That is actually it. Done. Now, just to show you what you would do to finish the problem, what you would do from there, you would graph that region. All right? So you would graph all of those constraints. You would find your vertices, and then you would evaluate that profit function, that profit objective function, for each vertex. And then you would look to see, well, this is my maximum. That's how I'm going to get the most money. So what I should do is I should sell 75 t-shirts and 15 sweatshirts to maximize that profit that I'm getting. Now again, I'm not going to make you take it that far. That would be a lot of work just for a single problem. You'd get maybe one done for the entire test. So what we're going to do, we're chopping off this bottom part. All you have to do is write me the objective function and write me your constraints. So we're going to do a couple more honing in on that skill. So let's look at this. A furniture manufacturer makes chairs and sofas from prepackaged parts. A chair requires 2 boxes of wood, 4 boxes of stuffing, and 1 box of fabric. A sofa requires 3 boxes of wood, 3 boxes of stuffing, and 2 boxes of fabric. The packages arrive once a week. The manufacturer has room to store 1,300 packages of wood parts, 2,000 packages of stuffing, and 800 packages of fabric. The manufacturer profits $200 per chair and $350 per sofa. How many chairs and how many sofas? Oh, I have a typo in there. I have too many ands. How many chairs and how many sofas should the manufacturer make each week to maximize profit? All right, so here again, the products we're talking about is what we put along the top. The chairs and sofas, and then a total column. What do we know about it? We know how much wood they take, how much stuffing they take, how much fabric they take, and what the profit is. So let's start filling in the table. So a chair requires 2 boxes of wood, 4 boxes of stuffing, 1 box of fabric. Sofa requires 3 boxes of wood, 3 boxes of stuffing, and 2 boxes of fabric. They have room to store 1,300 wood parts, so that's going to be my total for the wood. 2,000 stuffing packages, and 800 packages of fabric. He makes $200 per chair, $350 per sofa. And again, what we're looking for is we want to maximize that profit. So again, maximizing profit, that clues me in right away that this is my objective function. So my objective function, when we're talking about X and Y, $200 per chair plus $350 per sofa, that's going to be my profit. And that is my objective function. Whatever you're trying to maximize. And now everything else becomes a constraint. So this wood becomes a constraint. 2 for every chair, 3 for every sofa. I can only use up to 1,300. That's as many as the store area can hold. For stuffing, 4 per chair, 3 per sofa, and I can only use up to 2,000. For the fabric, 1 per chair, 2 per sofa, I can only use up to 800. And then, of course, you need those final 2 constraints because it's a real-world problem. You need everything to be 0 or positive. And again, nicing for the test, that's all you're going to have to do. What a business would do is then again, they'd graph it. They'd find those vertices. They'd plug those vertices into that profit function to maximize it. But again, that would take so long to do by hand. I'm not going to require you to do that for your test. All right, let's look at this one. Orangeade consists of 2.5 quarts of orange juice and 1.5 quarts of raspberry juice. Berry Fruity consists of 1 quart of orange juice and 3 quarts of raspberry juice. You profit 50 cents on every quart of Orangeade and 40 cents on every quart of Berry Fruity. The company has 500 quarts of orange juice and 600 quarts of raspberry juice. How many of each type should be made to maximize profit? So again, the 2 products we're talking about, Orangeade and Berry Fruity, so we put those along the top, along with the total column. What we know about them, we know how much orange juice they take, how much raspberry they take, and what you profit off of them. So let's fill in our table. So Orangeade consists of 2.5 quarts of orange juice, 1.5 quarts of raspberry juice. Berry Fruity takes 1 quart of orange juice, 3 quarts of raspberry juice. You profit 50 cents on Orangeade and 40 cents on Berry Fruity. They have 500 quarts of orange juice on hand, 600 quarts of raspberry juice on hand. And we're trying to maximize the profit. So I'm trying to maximize the profit. We identify this as our objective function. So that profit in dealing with X and Y, 0.5 for each X, 0.4 for each Y, and that is how we're going to determine our profit. Everything else becomes a constraint. So for orange juice, 2.5 for every X, 1 for every Y, we only have up to 500 to use. For raspberries, we need 1.5 for every X, 3 for every Y. We only have up to 600 to use. So those are all the constraints from the table, but then again, don't forget our hidden constraints. Because it's a real-world context, you need everything to be positive. All right, let's practice with one more, and then we will be done. So an office has 60 square feet of floor space and $600 budgeted to them. Cabinet A requires 3 feet of storage space, 12 cubic feet of floor space, 12 cubic feet of storage space, and it costs $75. Cabinet B requires 6 square feet of floor space, has 16 cubic feet of storage space, and costs $50. How many of each cabinet should be bought to maximize storage space? So let's put in our information. So there's a total of 60 square feet of storage space, or a floor space, I'm sorry. And they have $600 budgeted to them. Cabinet A requires 3 feet of floor space, gives you 12 feet of storage space, and costs $75. Cabinet B requires 6 feet of floor space, gives you 18 cubic feet of storage space, and costs $50. You're trying to maximize storage space. So that tells me that this storage space, that is my objective function, because that is what I'm trying to maximize. So 12 for the x and 18 for the y, that's how I'm going to calculate the total storage space that I'm getting. That is what I'm trying to maximize. Everything else becomes a constraint. So 3 for every x, 6 for the y's. I have up to 60 square feet of floor space. My budget, $75 for x, $50 per y. And I have up to $600 budgeted. Then, of course, my two constraints that I have to put, because it is a real world context. We only want positive values. And that is how you set up these systems. All right, so we've gone over numerous examples. So what I want you to do is now summarize what you've taken away from this. Summarize what you're going to remember from this lesson, how to solve these. Then, after you have all this filled out, bring it back to class and then be ready for your practice work.